This is a video from section 5.4. The directions say to find the general indefinite integral. So we're going to do some more examples in this video. I gave you a list in the last video of a table of indefinite integrals that we do need to know and that we need to know well. Okay. So let's go ahead and start here. Suppose I had the integral of 1 plus r divided by r to the second power dr. So we don't have any techniques to handle problems like this, and so we need to simplify this integrand. So I'm going to write this as 1 plus r to the second divided by r to the second dr. And I'm going to square out the numerator. So this is 1 plus 2r plus r squared, all divided by r squared dr. Okay. Now, typically when you have a problem like this, you should split off the fraction. And so this is 1 over r squared plus 2r over r squared plus r squared over r squared, this whole thing dr. Okay, and this is the integral of r to the negative 2 plus 2r to the negative 1 plus 1 dr. Now, it turns out this is r. If I add 1 to this exponent and then divide by that result, I should get r to the negative 1 over negative 1 plus, now the integral of 2r to the negative 1 is 2 times the natural log of the absolute value of r. The integral of 1 is r, and then you add c. And then if I just take it one step further, I get negative 1 over r plus 2 natural log of the absolute value of r plus r plus c. So we're looking for a family of functions whose derivative is 1 plus r over r to the second power. So that's example 1. Example 2. Suppose I had something like this. Suppose I had the integral of secant t times secant t plus tangent t dt. Now, what I would do is distribute the secant inside. And so I get the integral of secant t. And notice my use of these brackets, right? Because I'm taking the integral of the whole thing. And so let me actually write secant t times secant t is secant squared t plus secant t tangent t dt. Now, I'm going to do this on the next line as an option. I didn't do it over here in the first example when I got up to here. But if it helps, break apart the integrals. So I definitely want to show you both ways, and your instructor might prefer that. And so we have the integral of secant squared t dt plus the integral of secant t tangent t dt, right? Now, can you tell me the function whose derivative is secant squared t? And that's tangent t, okay? And the function whose derivative is secant t tangent t is secant t. And then I add c. Now, as a check, if I take the derivative of tangent t plus secant t plus c, well, the derivative of tangent t is secant squared t. So, well, that's good. And then the derivative of secant t is secant t tangent t. And the derivative of this constant here is 0. So it does check out. You do get that integrand. In other words, you get the thing you're trying to integrate. Example 3. Suppose I had the integral of sine 2x divided by sine of x dx. When you do a problem like this, remember that sine 2a is 2 sine a cosine a. So that's the double angle identity for sine. And so I'm going to take that and use this in the problem. So I'm going to write sine of 2x is 2 sine x cosine x. So anytime you get to use a trig identity, you want to try to take advantage of it when you can. Because, and by the way, the denominator is sine of x, and so I'm going to kill off the sines. And so I have the integral of 2 cosine x dx. Now, remember, can you tell me the function so that when I take the derivative, I get 2 cosine x? And the answer here is 2 sine x. But remember, you're looking for a family of functions, so you're going to add c. And that's how you do example 3. Now, the directions say evaluate the indefinite integral. Well, actually, we're going to do definite integrals. And with definite integrals, you have a lower limit and an upper limit. So we're going to practice some more. So let's take a look at example 4. So on example 4, suppose I had this one. The integral from 1 to 2 of 4x cubed minus 3x squared plus 2x dx. Now, again, if you need to break up the integral, like I did over here, that's fine. But I want you to have that as an option. And you also want to make sure you check with your teacher to make sure your teacher wants you to break up the integral. Now, if I take the integral of 4x cubed, I get x to the 4th. Here, let's do this. Let's make sure we're okay. So I'm going to take 4 times 1/4 x to the 4th minus 3 times the integral of x squared dx is 1/3 x cubed plus, now here I'm going to write 2 times 1/2 x squared, and I'm going to evaluate from 1 up to 2. Now, the 4's cancel, and you get x to the 4th minus the 3's cancel, we get minus x cubed. The 2's cancel, we get plus x squared from 1 to 2. So I'm going to pop the 2 in, pop the 1 in, and subtract. So I get 2 to the 4th minus 2 to the 3rd plus 2 to the 2nd minus 1 to the 4th minus 1 to the 3rd plus 1 to the 2nd. Now, this is 16 minus 8 plus 4 minus, the 1's cancel and you're just subtracting 1. And so the answer is 11. Let's take a look at example 5. Suppose I had the integral from 0 to 1 of 4 times over 1 plus x squared dx. So I'm going to pull the 4 out in front of the integral, and I'm going to take the integral from 0 to 1 of 1 over 1 plus x squared dx. But the integral of 1 over 1 plus x squared is arctangent of x. Okay, So I just need an antiderivative that works. I just need one function, in other words, whose derivative is 1 plus x squared. 1 over 1 plus x squared. But remember that I'm evaluating from 0 to 1. So I'm going to replace x with 1 and x with 0. So I get arctangent of 1 minus arctangent of 0. But arctangent of 1 is pi over 4. And arctangent of 0 is 0, and so the answer is pi. So let's take a look at example 6. Suppose I had the following. Suppose I had the integral from -1 to 1 of t times 1 minus t to the second power of dt. And so what I'm going to do is I'm going to expand out 1 minus t. So I get t times 1 minus 2t plus t squared dt. So I'm going to distribute the t in, like so. And I'm going to get the integral from -1 to 1 of t minus 2t squared plus t to the third dt. And so when I go forward, the antiderivative of t is 1/2 t squared. And then I'm going to get 2 times the antiderivative of t squared, which is 1/3 t cubed. And the antiderivative of t to the fourth is 1 over 4 t to the fourth. But I'm going to evaluate this from -1 up to 1. And remember, I'm going to pop the 1 in, pop the -1 in, and subtract their results. So when you put a 1 in and square it, you get 1, right? So here, I'm going to get the following. I'm going to get 1/2 minus 2/3 plus 1/4. And then I'm going to put in -1. I'm going to get 1/2 plus 2/3 plus 1/4. 1/2 plus 2/3 plus 1/4. And what ends up happening is this. So the 1/2s can cancel, the 1/4s can cancel, right? And what you end up getting is -2/3 minus 2/3. So the correct answer here is -4/3. And that's how you do this example. If we keep going, so that was example 6. So if we take a look at example 7, we get the following. Suppose I had the integral from 0 to 1 of 5x minus 5 to the x dx. And so this is going to be 5 times 1/2 x squared minus 5 to the x over natural log of 5. And I'm going to evaluate this from 0 to 1. So remember, when you integrate a to the x dx, this is a to the x over natural log of a plus c. So remember, we're going to go backwards. So we divide by natural log of 5. I'm going to plug the 1 in, and I'm going to get 5 times 1/2 minus 5 to the first over natural log of 5. And then I'm going to plug in 0, and I'm going to get 5 times 1/2 times 0 squared, right? Minus 5 to the 0 over natural log of 5. But 5 times a half is 5 halves, so we get 5 over 2 minus 5 over natural log of 5. And then when I subtract a negative, I add. So I get 1 over natural log of 5. And so the correct answer here is 5 over 2 minus 4 over natural log of 5. And that's example 7. So let's do one more example for this video. Suppose I take a look at example 8. Suppose I take the integral from 0 to pi over 4 of 3e to the x minus 4 secant x tangent x dx. Remember that the antiderivative of e to the x is e to the x. So we get 3e to the x minus the antiderivative of secant x tangent x is secant x. So we get minus 4 secant x. And then I'm going to evaluate this from 0 up to pi over 4. So when I plug in pi over 4, I get 3e to the pi over 4 minus 4 secant of pi over 4. And then when I plug in 0, I get 3e to the 0 minus 4 secant of 0. And so here I get 3e to the pi over 4. Secant of pi over 4 is square root of 2. So this is minus 4 square root of 2. And then I'm going to subtract. E to the 0 is 1. 1 times 3 is 3. So you get 3 minus 4. And so when I go to simplify, I get 3e to the pi over 4 minus 4 square root of 2. Minus a negative 1 is plus 1. And that would be the answer for example 8. And that'll conclude this video for section 5.4. And we did more examples of the indefinite integral as well as more examples of the definite integral. Okay, thank you.